From recent studies, the human eye seems able to see up to 8 million different colors. On the other way, TV screens, computer monitors, and smartphones cannot reproduce such a high number of hues. But there's another problem, which is way bigger. Every screen is different and made by another company, so how can we be sure that our images stay the same on other devices? That's why we need to understand color space and color profiles. Let's start with color spaces. A color space is just a group of colors. It could be an arbitrary group like the Pantone collection or something with mathematical perfection like sRGB. Here we can see a representation of many color spaces compared together. So if we pick the space of all the visible colors, which looks like an horseshoe, we can easily see that, for example, sRGB can portray just a part of it. But unfortunately, that also means all the devices working in sRGB show fewer colors than those working in Adobe RGB. Then, why we don't work with Adobe RGB? Because the most extensive user base defines the standard. There are more sRGB devices on the planet than Adobe RGB. Apple created Adobe RGB to solve a significant printing problem since it covers the CMYK space entirely. That's one of the reasons why printing and graphic companies often work with Apple products and Adobe RGB. Anyway, a color space needs a color model, which is the way colors are represented. Think about this for RGB or this for CMYK. Three values between 0 and 255 define an RGB color, for example. In another way, a color model is a way we use to describe a color using numbers. 25500 is pure red, for example. To define a color space, all we need is to map those numbers on the visible color map, or if you prefer, to find the right place for each triple or quadruple. To do so, we need a reference. The usual standard reference is the lab color space, which was designed to englobe all the visible colors. Thus, we can define a color space with a function between our color model and the lab color space. The area covered by the color space is called gamut. Working on Windows with 3ds Max, we use sRGB as the standard color space. That's because 3ds Max works in sRGB, internet browsers work in sRGB, and monitors usually work in sRGBs. To ensure your image will be displayed correctly on other devices, you need to save an ICC profile inside it. In this way, in an ideal world where all the monitors are calibrated, whoever opens the file will know the color space we used and see the same result. Remember always to check the ICC profile when you save an image. What happens if we need to print an image in CMYK? Well, first of all, CMYK is not a color profile, but rather a color model. Therefore, we need to know which specific color profile will be used to print. Let's say, for example, that the printing company works with Fogra 39. Both sRGB and Fogra 39 are mapped so that we can go from one to the other. Unfortunately, the sRGB gamut doesn't completely cover the Fogra 39 gamut. For this reason, some colors are going to be lost during the conversion process. If we know that we will convert the image to CMYK from the beginning, it's mandatory to turn on color proof. We will avoid using those tones by default because we cannot even see them. Remember, it's never a problem to convert to a color space with a more extensive gamut. But on the other way, if you go to a smaller gamut, some colors might get lost and replaced with the closest one. To manage color profiles, go to Edit, Color Settings, or press Ctrl-Alt-K. Another thing, for digital devices, there's a gamma value associated with it because monitors need luminosity to define the brightness darkness of a color. For sRGB, should be 2.2, for Adobe RGB 1.8, etc. Gamma is a crucial factor when we import textures in 3ds Max.